Welcome back, grade 9. Hope your studies are going well and all are safe and well at home. In chapter 2, let's move on to your new lesson today, 2.5, Factorization of Polynomials. We will start with a simple example, 8 divided by 2. You know that 8 divided by 2 is 4 and the remainder is 0. This remainder 0 is giving us two information, which we have looked into remainder theorem. So the remainder is 0 means that 2 is a factor of 8 and 8 is a multiple of 2. So here in this lesson, we will concentrate on the factor, the word factor. So remainder is 0 means 2 is a factor of 8. Now let us see what does factor theorem say. Factor theorem actually is just a repeated statement from remainder theorem. Factor theorem says that x minus a, the divisor, is a factor of the given polynomial if the remainder is 0. Or we can also state that remainder is 0 if the divisor is a factor. This will be easy when you check from here. See, 2 is a factor, so the remainder is 0. Remainder is 0, so 2 is a factor. It is just a statement restating from one form or the other form. Now let us see more details about factors. The word factors, whenever you hear the word factors, remember that factors of any number starts from the number 1. Let's see an example. Factors of 100 starting from 1. If you write them in pairs, it will be so easy for you. Start from 1. So 1 times 100 gives you 100. After 1, we have the number 2. 2 times 50 will give you 100. The next number is 3, but in timetable 3, you know that we don't have 100, so skip it. After 3, 4 times 25 is 100. After 4, 5 times 20 is also 100. After 5, in timetable 6, you know that we don't have 100, timetable 7, timetable 8, timetable 9. None of these numbers have 100 in their timetable. Now the next number is 10, and 10 times 10 is 100. Once you reach the same number or near numbers, you can stop thinking about the number 11, 12, 13. We don't have to. Once you see exactly the same number or the next number, you can stop there. So what are the factors of 100? Just write them in the order from 1 to the given number. 1, 2, 4, 5, 10, 20, 25, 50, and the last number will be the given number itself. Because every number has 1 and itself as the factors. Hope the word factors is clear to you. This is a simple idea. Now let us see how to factorize a given polynomial using factor theorem. Here keep in mind, always the constant is considered as the product of two numbers and the number, the coefficient which is with x without power 2. The coefficient with x is considered as sum of two numbers. This is very important. Or we can say the middle term, we get it by adding two numbers. And the same numbers, when you multiply, you have to get the number 6. And you know that the factors of 6 are 1, 2, 3, and 6. Because 1 times 6 is 6, 2 times 3 is 6. Now let us factorize this in two methods. The first method is the easiest method, but we can only do it when you have the coefficient of x square is 1. This has only one step, but remember, you have to do it when you have coefficient 1. But when you have coefficient 2, 3, for any other number, we will do the second method. So moving on, let's see what are the two numbers. When you multiply, you will get the number 6. On multiplication, you will get the number 6 or positive 6. And the same numbers, remember the same numbers, when you add, you will get the number negative 5. Okay, so the numbers are, let's say 2 times 3 is 6. Positive 2 and positive 3 is 6. Yes, it's fine. And 2 plus 3 is 5, but it is not negative 5. So we have to think again. To get negative 5, both of the numbers should be negative. And let us see how does it work with the positive sign. Negative 2 and negative 3 is positive 6. Yes, correct. Negative 2 plus negative 3 is negative 5. So the two numbers are negative 2 and negative 3. These are the numbers that you have to substitute. So the method is from the polynomial x square minus 5x plus 6. This is the question. And how do we write? We have power 2. So we open two brackets because factorize means we are writing two factors. X power 2. So x in the first one and x in the second one. As I told you, the coefficient is 1, so we don't have to bother about it. Now, what are the factors? Negative 2 and negative 3. Just fill it up here and we are done with one step. This is one of the easiest way. But remember, this method works easily only when you have the coefficient 1. Now, what are we going to do when you have coefficient other than 1? We will see it now in method 2. This works in any coefficient 1 or 2 or any coefficients. This is called splitting the middle term. Okay, so the polynomial is x square minus 5x plus 6. And we found out that the factors, again, we have to find out the factors here. So the factors are negative 2 and negative 3. So split the middle term. So middle term will be repeated as negative 2x and negative 3x. Negative 5x is rewritten as negative 2x and negative 3x. At the same time, the first term and the last term remains the same without any change. Okay, now we consider them as two groups. First group with the first two terms and the last group with the last two terms, which is equal to, in the first group with two terms, what is common? We can see x is here, x is here. So we take x outside. Excellent. When you take x outside from x power 2, we have x is left minus, from 2x we take x outside, so 2 is left. We are done with the first group. Now, in the second group, it's starting with a negative, so let's start with negative. 3x and 6, what's common? 3 is common, so take 3 outside. Now what is left here? Only x, because negative is removed, 3 is removed, so x is left. Now be careful, we have negative 3 outside. Negative 3 times what give you 6? Yes, negative 2. Now again, if you are confused here, the first bracket will give you an idea. X minus 2, this should also be exactly the same. And you can check yourself. Negative and negative is positive. 3 times 2 is 6. Now look at the two terms. The first term is from here until here, and the second term is from here to here. What's common in two terms? Yes, x minus 2 is common. So the common term, take it outside, or common bracket, we take it outside. When you take x minus 2 outside, what is left in the first term? X is left. And what is left in the second term? Minus 3 is left. All of this will go to the second bracket, and that's your answer. See now? These two are exactly the same. Isn't it wonderful? Excellent. Now let's move on to a little bit larger polynomial. X cube, whenever it starts with power 3, it will be a little more lengthy. So as usual, we start with the constant, which is 120. The factors of 120, again, as I told you, the factor starts from 1. 1 times 120 is 120. After 1, yes, in timetable 2 also we have 120, 2 times 60. In 3 also we have 3 times 40, 4 times 30, 5 times 24, 6 times 20. In timetable 7, we don't have 120. Now we will move on to 8 times 15. In times table 9, we don't have 10 times 12. After 10, 11. 11 times 11 is 121. So we don't have. After 11, 12 is already there. Once you return, you can stop thinking about it. So what are the factors of 120? We can just write it down in the order like a U shape here. So what are the factors? 1, 2, 3, 4, 5, 6, 8, 10. These are here. 12, 15, 20, 24, 30, 40, 60. And when you reach the same number, you can stop. These are the factors of 120. Now, since we have power 3, we can't split the middle term, and even there is no middle term here, there are two terms. So what we are going to do is we substitute and check when are we going to get a remainder 0. So first we will see what is P of 1, because 1 is a factor. If 1 is not working, we have to see P of minus 1. Again, if it's not working, we will see P of 2, then P of minus 2, P of 3, P of minus 3. These are the ways how you check it. So let's see the first one. X power 3 means 1 power 3 minus 23 1 power 2 plus 142 times 1 minus 120. Now let's see the answer. 1 minus 23 plus 142 minus 120, which is equal to 1 and 142. Let's take the positive numbers. 1 and 142 is 143, and these two will be negative 143. Yes, we get the remainder as 0, which means 1 is a factor. So how x equal to 1 is a factor, which means we can say that x minus 1 is a polynomial that you can divide with x cubed minus 23x squared plus 142x minus 120. You will get a remainder 0. That's what we learned in remainder theorem. If the remainder is 0, the divisor is a factor. Okay, now we have to do the long division so that this polynomial gets reduced by 1 power. Means the answer will be starting with power 2. Let's see how does it work using long division. Okay, so the polynomial is x cube minus 23x squared plus 142x minus 120 divided by x minus 1. Hope you understand how to get x minus 1. We got x equal to 1, so you have to move to the other side. So it will be plus changes to minus. That's how you get x minus 1. Now, as usual that we did in the previous period, x cubed divided by x is x squared. X squared times x is x power 3 minus 1 times x squared is minus x squared. What's the next step? Do you remember? Excellent. Change the sign. These two are removed. Again, this will be plus. Negative 23 plus 1, both of them are x squared. So negative 23 plus 1 is negative 22 because we have to put the sign of the larger number, x squared plus 142x. We write the rest of the terms. Okay, now again, negative 22x squared divided by x will be negative 22x because one of the x get cancelled. Multiply x times negative 22 will be negative 22x squared. Minus and minus will be plus. 1 times 22 is 22x. Again, we change the sign. So this will be cancelled. This will be negative. 142 minus 22 will be 120x. Take the new term down. 120x divided by x will be positive 120. Now, 120 times x is 120x minus 120. What's the last step now? Excellent. Change the sign. These two are removed. These two are removed. So we get the remainder 0. What do we understand when you get the remainder 0? X minus 1 is a factor. So how do we rewrite the given polynomial? This polynomial or the question can be rewritten as x minus 1 is a factor. And when you take this factor, the quotient will be the next number, x squared minus 22x plus 120 is the other term when you factorize this big polynomial. But still, can you see that there is an x power 2 with 3 terms? So we can split this by the first method or the second method as the first example. So let us take x minus 1, x squared minus 22x plus 20 and separate the middle term. So the number is x minus 1, x squared minus 22x plus 120. 22x plus 120. Now, so this is already done, nothing to do. The factors of 120 are the numbers. So when you multiply, you have to get 120, and when you add, you have to get 22. What are the numbers? When you multiply, we have to get 120. And the same numbers when you add, you must get negative 22. 12 and 10, great. So 12 times 10 is 120. 12 and 10 is 122. 12 and 10 is 22, but we need a negative sign. See, both of them are negative. Yes, it works. So the numbers are, the factors are negative 12 and negative 10. Now, how can we separate it? X square minus 22x plus 120 can be written as, again, the coefficient is 1. So open two brackets, write x in the first space, and the number is negative 12 and negative 10. So this is the factorization of this polynomial. And together with that, we had a polynomial x minus 1. So we can say that the factorization of this is x minus 1, which is from here, and the two factors that you get from here, x minus 12 and x minus 10. This is the factorization of this big polynomial. We have three factors because the power of x is 3. Excellent. Now let's move on to the exercise 2.4, question number 1. We have to check whether the following has x plus 1 as a factor. How do we check x plus 1 is a factor? We rewrite this is the divisor. So we rewrite the divisor x plus 1 is equal to 0. This was the first step that we did in remainder theorem as well. So x is equal to negative 1. We have to substitute x is equal to negative 1 in each of the polynomial. So x cube, here we have to substitute, which is equal to negative 1 power 3 plus negative 1 power 2 plus negative 1 plus 1. Let us see what's the answer. Negative 1 power 3 is negative 1. Negative 1 power 2 is positive 1. Negative 1, positive 1. These two get cancelled, these two get cancelled, so your remainder is 0. So what do we understand? Yes, it is a factor. X plus 1 is a factor because you have the remainder 0. Now the next example, again we can substitute negative 1. So negative 1 power 4 plus negative 1 power 3 plus negative 1 power 2 plus negative 1 plus 1, which is equal to negative power 4 will be positive, negative power 3 is negative, positive, negative, and 1. These two get cancelled, these two get cancelled, and you have the number 1. So this is equal to 1. Remainder is not equal to 0. So what do we say? No, x plus 1 is not a factor. Is that clear? Simple. When the remainder is 1, when the remainder is not 0, it is not a factor. Let's see more cases, which is part 3. We can rewrite. Again, it is negative 1 power 4 plus 3 negative 1 power 3 plus 3 negative 1 power 2 plus negative 1 plus 1, which is equal to power 4, so positive, power 3, so negative, positive, negative 1, which is equal to 1 minus 3 plus 3 minus 1 plus 1. So we have minus 3 plus 3 get cancelled, minus 1 plus 1 get cancelled. So we have a remainder 1 not equal to 0, so not a factor. X plus 1 is not a factor. Next one, x power 3. So negative 1 power 3 minus negative 1 power 2 minus 2 plus root 2 negative 1 plus root 2, which is equal to negative of 1, because power 2 will be 1, but this negative will stay negative. This negative and this negative will be positive. 2 plus root 2 plus root 2. Negative 1 is negative 2. So negative 2 and this will get cancelled. Root 2 and root 2 is 2 root 2. Is it equal to 0? Not equal to 0. So we can say that x plus 1 is not a factor. Excellent. This is a simple question in this exercise. Question 2. we have to see that the divisor is a factor or not. Here the divisor is x plus 1. As usual, we write the divisor is equal to 0. X plus 1 is equal to 0. X is equal to negative 1. So we rewrite 2 negative 1 power 3 plus negative 1 power 2 minus 2 negative 1 minus 1, which is equal to, power is 3, so negative 2 plus 1 plus 2, because negative and negative is plus, or positive, negative 1. So negative 2 and positive 2 get cancelled, 1 and 1 get cancelled. So what do we get? We say that the remainder is 0. So x plus 1 is a factor of, or we can say gx is a factor of p of x. Easy? Excellent. Now let's see the next example. Again, x plus 2. So we rewrite x plus 2 is equal to 0, or we say x is equal to negative 2. So p of negative 2 is equal to negative 2 power 3 plus 3 negative 2 power 2 plus 3 times negative 2 plus 1, which is equal to negative. So negative power 3 is negative with 8. It is positive. So 3 times 4 minus 6 plus 1, which is equal to negative 8 plus 12 minus 6 plus 1, which is, this is negative 14. Hope you know how to calculate the negative and positive numbers. Negative and negative, we can add them. So negative 14 plus 12 and plus 1 is plus 13, which is equal to negative 1, not equal to 0. So we can say that g of x is not a factor of p of x, because the remainder is not 0. Moving on to the third part of the same question, x minus 3 is equal to 0. Or we say that x equal to 3. So we substitute p of 3 is equal to 3 power 3 minus 4 times 3 power 2 plus 3 plus 6, which is equal to 27. Students used to make mistake. 3 times 3 is, it's not 3 times 3, it is 3 times 3 times 3, 27, minus 4 times 9 plus 3 plus 6, which is equal to 27 minus 36 plus 3 plus 6. Again, let's take all the positive numbers together. 27 plus 3 is 30 plus 6, 36, minus 36 equal to 0. Yes, the remainder is 0. So we know that the divisor is a factor of the given polynomial. Is that perfect? Let's move on to the next question. Question 3. They gave you that x minus 1 is a factor. So we can say x minus 1 equal to 0 or x is equal to 1. Then we have to find the value of k. So we replace x by 1 because they gave you it is a factor. So p of 1 is equal to 1 square plus 1 plus k should be equal to 0 because the remainder should be 0 because 1 is a factor. So 1 plus 1. 2 plus k equal to 0 or k is equal to negative 2. Done, because the question is, what is the value of k? In the first part, it is negative 2. Second part, again they said negative 1 is a factor. So we replace p of 1, which is equal to 2 times 1 square plus k times 1 plus root 2 is equal to 0. Again, I'm repeating, we put equal to 0 because they told you that it is a factor. It is a factor means when you substitute, you will get the remainder 0. So let us see what does it give you. 2 times 1 is 2 plus k times 1 is k plus root 2 equal to 0. We say that k is equal to 2 and root 2 should be moved. So negative 2, negative root 2. Or you can even rewrite this as negative outside 2 plus root 2. Both of them are the answers. So what's the value of k? Negative 2 minus root 2 or negative of 2 plus root 2. Question 3 now. Again, 1 is the factor. So p of 1 is equal to k times 1 power 2 minus root 2 times 1 plus 1 equal to 0. So we rewrite k minus root 2 plus 1 equal to 0. Or k is equal to root 2 will be positive and 1 will be negative. That's the answer. Very easy. Now the last part of today's period, which is p of x is equal to kx square minus 3x plus k. Again, we rewrite p of 1 is equal to 1 times k times 1 power 2 minus 3 times 1 plus k is equal to 0. We rewrite k minus 3 plus k is equal to 0. We have k here and k here, so we can take them together. 2k minus 3 is equal to 0, or 2k is equal to 3, because minus 3 changes to plus 3, 3 divided by 2. So the value of k is 3 by 2. Excellent. So I hope the exercise today was perfect and clear. Moving on to the homework. Show that this is the factor of this given polynomial. See, have you noticed this is not in the standard form? So the first step is you can rewrite them in the standard form. What is the standard form? X cubed minus x squared plus 11x plus 69. To check x minus 3 is a factor, so we rewrite x plus 3 is equal to 0, or x equal to negative 3. We rewrite negative 3 and just get the answer. If you get the remainder or the final answer is 0, which means it's a factor. If it's not 0, it is not a factor. Okay, and just one more example only today. Show that, or find the value of m. Just one more example today. Find the value of m if x minus 2 is a factor. X minus 2 is a factor, so we write x minus 2 is equal to 0. 100 times we have written now. You must be an expert in doing this. And we substitute p of 2, and what's the value p of 2, which we will substitute equal to 0, and the final answer will be the value of m. That's all for today. Have a wonderful day. Keep practicing. Love you all. See you in the next period. Bye for now.